So the first trend we're going to look at is size. So the size of the atoms or the elements. And it's actually kind of hard to define. And it's hard to define because remember, atoms aren't actually perfect spheres. And so some of the things that we look at are basically the radius of an atom during some kind of bond or non-bonding type of thing. And so there's actually multiple data points and multiple iterations that you can get. And so what we're going to look at is what's kind of generally known as the atomic radius. And it's really an average bonding radius across multiple measurements. So depending on what kind of measurements you have, there's going to be some kind of error. So if you look at these trends, you'll see some kind of weird things going on here and there, depending on which trend you're using. So we're just going to kind of use this general atomic radius trend. And so basically, for this kind of trend, what you do is you look an atom in a bond, and then you take the radius of it, right? 1/2 length of the bond. So there's an example for the halogens. And again, it's just really size. So if we draw our periodic table, and we think about how this trend looks, when we go from left to right and from down to up, we get smaller. So an example of a really small atom would be helium or something like fluorine. And then obviously in the opposite corner, we get much bigger. So really big would be somewhere down here, something like cesium or something like that. Here's a nice picture of that. So you can see as we go to the top right, we get smaller and smaller, and then the bottom left, we get bigger and bigger. The transition metals don't follow this as nicely. You can see they do kind of fit in terms of overall size, but when going from left to right, their size actually doesn't decrease that much. So that's what this picture shows. But the main point is the trend is top right is small, bottom left is big. Next up, we're going to take a look at the why behind this trend.